Hi, my name is Chukwuebuka Nweke. I'm an assistant professor. My research is focused on understanding earthquakes and how the earthquakes make the ground shake, how to amplify it, how to design against it, how to prepare for it, how to estimate it, and how to essentially increase life safety. When an earthquake happens and you're standing either in a building or open field, how much does the building shake? How much does the ground shake? Does the ground get softer? Does the building collapse? Does the building bend over? My goal is to understand those phenomena and try to design against it and essentially prevent society from any kind of disasters and make it for a safer infrastructure. You have to collaborate with data scientists. You have to use a lot of computing, algorithms. We also have testing sensors that we use to essentially capture data when we need it, some seismometers. So there are a number of things that we use, but primarily we use a lot of computing power and a lot of sensors. So my research is quite impactful actually because it's actually tied directly to life safety and design. So a lot of the work that we're doing is again trying to understand how much is going to happen during an earthquake. And when I say how much is going to happen, how much shaking is going to happen, how much damage is going to happen. So our work directly impacts the codes that are used to design buildings, that are used to essentially analyze post-earthquake hazards. So what if an earthquake does happen, how do we quickly recover from it? So we are all-encompassing, focused, hazard-based research group. Our goal is to essentially make things easier for engineers to design and make things safer for the community. Oftentimes we don't really think about how much buildings can handle, how safe a building is. You kind of assume that it's doing its job, but in the seismic region, that's not necessarily the case for many of these buildings. So what our research is going to do is essentially change the codes and make the codes better so that every future building that's built will give you the peace of mind. For instance, let's say you go to Disney Concert Hall or some skyscraper downtown or some building down here on campus. You will feel safe to walk in that building and know that in the event of an earthquake, you will be okay because the building will be okay. And that's what our research is going to impact.